Hi, Mrs McTaggart here. In this video, we're going to look at some basic National 5 style trig equations, but we're going to be using exact values with them, which you should previously have already learned in the higher exact value and radian topic. So we've got the equation solve 2 sin x equals 1, and we have to find our answers between 0 and 360. Now at National 5, this bit here didn't mean too much. We never really looked at it, but at higher, it actually tells us what we're working in, whether it's degrees or radians, and it tells us what answers we're looking for, because you can have answers, remember, from all 4 quadrants from 0 to 360. This will tell you if you're maybe only focusing on a couple of the quadrants or on the full thing. So we want any answer between 0 and 360, and because it says 360, then we are wanting it in degrees. So first things first, as with any trig equation question, you have to change the subject first and get it into the form sin x equals. So if I divide by 2, this gives me sin x equals 1/2. Now from your exact values, the 1/2 we should know without going to a calculator. If you're not sure, so the 1/2 came from the isosceles triangle. No, it didn't. It came from the equilateral triangle with sides of 2. When you cut down in the middle, it gives you a 1 there. Now it doesn't really matter what this other side is because I don't need it, because there I've got my half. So my 1 is my opposite, so the angle is 30. 1 over 2. Sin 30 gives you 1 over 2. So the acute angle is 30 degrees. Now my fraction is a half, which is positive. So I'm going to use the all and the sign boxes. Okay? Because the fraction is positive. Remember, that table tells you where all your graphs are positive. So sin x of a half, the answer that it gives us is 30. So our two answers are x equals 30 in quadrant 1, and x equals, remember in the sign box you do 180 take away 30. So our two answers are 30 and 150 degrees. Okay, now just to show you what was going on here is, remember, this is your sine graph. This is 0 up to 180. And this would be 1, and this would be your half, about halfway. And there's your two answers, 30 and 150. 30 away from your 0 and 30 away from 180 gives you the 150. Okay, let's look at another one. This time, first thing to look at is up here we've got it between 0 and 2 pi. Now sometimes this will have a theta symbol in it instead of an x, and that tells us we want our answers in radians. Now it's perfectly okay to feel free to work in degrees and convert to radians at the end, but we are aware that we're doing radians straight off. So again, we're going to rearrange this one. So this would go to root 2 cos x equals -1. And I know some people do this all in one go, but I'm doing it every step individually. And then that gives me -1 over root 2. Now, because my fraction is negative, I'm going to discuss that first before I get the acute angle. Because my fraction is negative, I am not using all in cos, so I'm not using them this time. I'm using sine and tan. Now, what gives us 1 over root 2? So the root 2's come from the isosceles triangle with your 45, where your sides are 1, 1, and Pythagoras to get the root 2. So both sine and cos of 45 give you 1 over root 2. So my acute angle is 45 degrees. Now in the sine box, that would be 180 minus 45. And in the tan box, that would be 180 plus 45. Now that gives us 135 degrees and 225 degrees. Now the 45 degrees is the equivalent of 180 over 4, so pi over 4. Now that first one is 3 lots of 45, so 3 pi over 4. And the second one is 5 lots of 45, so 5 pi over 4. So if you know some of your exact values off by heart, you can get all the related ones really quickly and easily. Okay, that's that one. And then the last one I'm going to do is a little bit trickier. This time I've got sine squared x equals 3/4. Now, sine squared x is really sine x all squared. And the reason they put the wee into in there, what I say it is anyway, is because if they didn't, it would just look like sine x squared, right? Which is completely different. So this is a graph of sine x all squared, and that gave us 3/4. Now in maths, whenever you've got something squared, we know to take the square root of the other side. So we're going to take the square root of 3/4. Now you can split that up and do the square root of top and the square root of bottom. So that gives us sin x equals root 3 over 2, which of course this is non-calculated. We're looking for our exact values. Now, one little thing to mention before I go any further is technically, if I ask you the square root of 9, you will tell me 3. But someone who's on the ball will actually tell me, well, it could be plus or minus 3, because 3 squared is 9, minus 3 squared is also 9. So the same happened here. So actually, the square root gave me, it should have been the square root of plus or minus this answer. So plus of minus root 3 over 2. Now that means when I come to do my all sine tan cos table, I'm looking for the sine graph to be positive, so all in sine. And I'm also looking for it to be negative, so I tick tan and cos. And theoretically, there should be 4 answers. Okay, so there's 4 answers here. However, you need to go look at this. I only want the ones between 0 and pi. So I only want the ones between 0 and 180. So it's only the first 2 that are of interest here. Okay, so it's only the first 2 that are of interest here. And sometimes it's the other way around and you only want the last 2. So actually, I'm only going to use the sine and the all box. Now, what gives us root 3 over 2? Now, we already knew sine 30 was a half, so we know it's not 30. I'm thinking it's the 60. So let's go to our equilateral triangle again. We split it down the middle, which gives us 2 and 1. 60 is there, 30 is there. 2 squared take away 1 squared is 3, so this side is root 3. So to get root 3 over 2, this is my opposite, 2 is my hypotenuse, so it is 60. So my acute angle is 60. So in the all box, x is 60 degrees. And in the other one, it's 180 minus 60. Now, it was in radians, so 60 is a third of pi, so that's pi over 3. 180 minus 60 is 120. I've missed a wee line in there, I should have probably written 120 first. So x is pi over 3 and 120 is double that, so 2 pi over 3. Okay, and that's my 2 answers there. So technically, remember, there should have been 4 answers, and I could have gone on and worked out quadrant 3 and quadrant 4, but then I would have just had to score them out and say, oh, they're out with the range that we're asked for, out with the domain I've been asked to, sorry, out with the range. This thing here's called your range. That's the range of answers we want at the end. But if that wasn't there, if that just said 0 and 2 pi, you would find all 4 quadrants, okay? So, okay, and this is just 5 examples that I did with my class that you could try if you wanted. We mixture, some degrees, some radians. There's a couple of squared ones in there. Just be with question 4 because it's only 0 to pi. That one will only have 2 answers. And again, all non-calculator, all using exact values. And this last little one that's been scored out is because I did work out that answer and realised that that was smaller than pi and it wanted it between pi and 360. So that one was ruled out. Thank you for watching. Bye-bye.